अस्सलाम वालेकुम व्यूवर्स, उम्मीद करता हूँ आप सब खैरियत से होंगे। आज का हमारा टॉपिक सीरीज सॉल्यूशन ऑफ ओडीज के बारे में है। आज हम समझेंगे कि सीरीज सॉल्यूशन किस तरह से लिखी जाती है और सीरीज सॉल्यूशन किस पॉइंट के लिए पॉसिबल होती है और किस पॉइंट के लिए पॉसिबल नहीं होती। जैसे कि हम जानते हैं हमारे पास दो तरह के पॉइंट्स होते हैं, ऑर्डिनरी पॉइंट एंड सिंगुलर पॉइंट। नंबर वन, ऑर्डिनरी पॉइंट। लेट टेक एन जनरल ODE as p of x into d square y by dx square plus q of x into dy by dx plus r of x into y is equals to 0, which is equation number 1. So, if we put x is equals to x naught, a specific point in p of x, then p of x naught is not equal to 0, so it is an ordinary point. Let us understand with the help of an example as Legendre ordinary differential equation as 1 minus x square into d square y by dx square minus 2x into dy by dx plus n into 1 plus 1 into y is equals to 0, which is equation number 2. So here p of x is equals to 1 minus x square, q of x is equals to minus 2x, r of x is equals to n into n plus 1. So at x is equals to 0, p of 0 is equals to 1, or p of x naught is not equal to 0. So this point x is equal to 0 is an ordinary point. And for an ordinary point, the solution of the ODE can be expressed in the form of the series. And now, point number 2, singular point. If we put x is equals to x naught in p of x and p of x naught is equal to 0, then the point is singular point. As the general ODE as p of x into d square y by dx square plus q of x into dy by dx plus r of x into y is equals to 0. Now rearranging it by dividing the p of x on both sides, then the desired result is d square y by dx square plus q of x by p of x into dy by dx plus r of x by p of x into y is equals to 0. So, if q of x by p of x and r of x by p of x becomes infinite, then it is called a singularity. And as the singular point has two further subtypes as regular singular point and irregular singular point. Number 1, regular singular point. If we have x is equals to x naught in p of x and the term p of x naught is equals to 0, then the point is singular point. And if we apply a limit x approaches to x naught at x into q of x by p of x and the desired result is finite, and the also applying limit at x square into r of x by p of x at x approaches to x naught, and it will also give a finite number. Then, if all three conditions are satisfied, then the point is a regular singular point, and the series solution are possible for it. Now, point number 2, irregular singular point. If we put x is equal to x naught in p of x, then p of x is equals to 0, then the point is singular point. And if we applying limit at x approaches to x naught at x dot q of x by r of x, and we obtained an infinite number. Similarly, we applying a limit x approaches to x naught at x square dot r of x by p of x, and we obtained a infinite number. Then the point is a irregular singular point. And for this point, the series solution is not possible. Let us understand with the help of an example as Basel's equation. We are checking the ordinary or a singular point for x is equal to 0 for the Basel equation as by comparing it with the general equation as we obtain p of x is equal to x square. Here 2 is a misprint. So p of x is equal to x square, q of x is equal to x, r of x is equal to x square minus n square. So if we put x is equal to 0 at p of x, then we obtain p of 0 is equal to 0. Then it shows that it is a singular point. So now, if limit x approaches to 0, applying at x into q of x by p of x, and we obtain as 1, which is a finite number. Similarly, by applying limit x approaches to 0 on x square into r of x by p of x, and the desired result is minus n square by 2. So it indicates that the desired result, or the point x is equals to 0, is a regular singular point. So a series solution is possible for this point. Here is an assignment problem. As now we are checked the ordinary or singular point for x is equal to minus 1. It is an easy example. You can solve it by yourself. And now, as the series solution, if the point is ordinary or regular singular point, then the solution is can be expressed or written in the terms of power series or Frobenius power series. The general form of the power series or Frobenius power series is y is equals to summation from n is equals to 0 to infinity cn into nth power of x minus x naught. So if the series is converging going from a higher number to a smaller number, then this will give the finite number, and we say that the series is convergent. And now first we will find the regular singular point for this the above ODE, and then we will write its series solution. And now the distance between ordinary point and singular point is called the radius of the converging series. Let us consider with an example as 1 plus x square into d square y by dx square plus 2x dy by dx plus n square y is equals to 0. It is an ODE. So p of x is equals to 0 at x is equals to plus minus 1 iota. X is equal to plus minus iota. So as we know that iota is always draw on y-axis. So by drawing on the graph of two-dimensional system, then we will obtain as 0 to plus iota a vector, and this vector is the radius of the converging series.